Hi, this is Abigail Layugan, a 5th year architecture student, Black B. And today's topic is all about the strength reduction factors. But before that, we will have introduction about reinforced concrete design. So what is concrete and reinforced concrete? So ang concrete, ito ay mixture of sand, gravel, crushed rock, o other aggregates held together by cement and water. At kapag itong concrete ng steel, ito na ngayon yung tinatawag na reinforced. So under reinforced concrete, ano yung strength reduction factors niya? Ito ay ginagamit in every engineering design. Ginagamit yun upang paliitin yung tinatansyang tibay ng mga structure o yung mga structural members. Pero ano ba yung different types of reduction factor? So, different types of reduction factors. Una, hydrogen. Pangalawa, fiber-reinforced polymer. Pangatlo ay yung permeation. So, dun tayo sa under ng fiber-reinforced polymer. Ang fiber-reinforced polymer are composites used in almost every type of advanced engineering structure, with their usage ranging from aircraft, helicopters, and spacecraft, through to boats, ships, and offshore platforms, and to automobiles, sports goods, chemical processing equipment, and civil infrastructure such as bridges and buildings. So, example of strength reduction factors is to compute the design strength of concrete elements. It is used to account for uncertainties in materials, possible design, and construction errors. Ang mga scientists natin, di ba, minsan sobrang excited sa mga bagong experiments nila, and that is an opportunity for them to learn something new about the world. And they can always change a little bit of the experiment and try again next time. While in engineering, it is different. The designers and engineers is prefer to find something wrong before it's building instead of after, because engineering failure can be a disaster. So in short, ang strength reduction factors, ginagamit ito para malaman ng patiuna ng ating mga civil engineer and structural engineers kung magkakaroon ng mga construction errors dahil sa design o pagbabago ng materials. The ACI 318-19 specifies the strength reduction factors for different concrete elements like beams, columns, slabs, and for various forces that influence the members such as moments, shears, and torsions. So, itong ACI 19, ito yung code for structural concrete na nagpo-provide ng minimum requirements and to provide public health and safety for the design and construction of structural concrete buildings. So, this is the table of code na our engineers considering on doing structural plans. From ACI, andito naman sa Pilipinas ay may tinatawag na NSCP 2015. So, paano ba ginagamit itong code for strength reduction? For example, gagamit tayo ng column na merong 30 megapascal strength. So, we will multiply this with the given strength reduction factor na magagaling dito sa code. So, yung magiging product nun ay i-consider on designing the reinforced concrete. So, purpose of strength reduction factors. So, ano bang purpose ng pag-compute ng strength reduction factors? Una, ay para tuusin yung maaari kamalian ng disenyo. That's why we use the NSCP 2015 code for computing of the strength reduction factor. Pangalawa, ay para makita yung kahalagahan ng bawat structural members. Structural members ay yung primary load bearings components of the building, and each have their own structural properties which need to be considered. Ito yung beams na horizontal members na nagtatransfer ng loads to support. Yung column na vertical members na nagtatransfer ng compression load to the ground. Nandyan din yung girder, floor decking, and the roof decking. Pangatlo, para mataos yung mga probable understrength of structural elements. Minsan dahil sa maaaring pagbabago ng material strength at dimension ng concrete member. So, ang pang-apat ay para malaman natin yung kunat at needed reliability ng structural member under load effects. So, the next reporter will be Miss Clarisse Gutierrez. She will be discussing the important notes regarding this topic.
Good morning, everyone. Yung topic ko po is all about notes of strength reduction factor of compression control and tension control member. The strength reduction factor for the compression control member is 0.65. The compression control member is brittle and fail suddenly without showing any sign of failure, such as large deflection. Additionally, the compression control elements are sensitive to variation in concrete properties. So, ang sabi nga dito sa strength reduction factor, they reduce the calculated strength structure member para malaman nila yung exact load ng mga materials na gagamitin. Para na din maiwasan yung mga maling paglalagay ng bakal, sukat at iba pang factors na pwedeng makapag-fail sa isang structures. ACI Code 9.3 provide different value of P for different situation. I will mention some of these values. 0.90 for tension control, beam and slab. 0.75 for shear and torsion in beams. 0.65 or 0.75 for columns. 0.65 or 0.75 to 0.9 for columns supporting very small axial load. 0.65 for bearing on concrete. See, compression control section is equal to P equal 0.65 because the section is brittle. What is brittle? Brittle is a property of metal which state that they do not deform under load but suddenly break. These brittle materials absorb less energy from their breakage or fracture, even when the materials have high strength. Si brittle is nagpe-fail siya ng walang sign or warning. Bigla-bigla na lang siyang masisira. Dito nagkakaroon ng large deflection. So, ano nga ba yung mga variation in concrete properties? Number 1, mechanical strength, in particular compressive strength. 2, durability. 3, porosity and density. 4, fire resistant. 5, thermal and acoustic insulation properties. 6, impact resistant. Compression control section. Section where the net tensile strain in the outermost layer of steel is at or below the yield strain. Compression control section, bakit nga ba natin dapat lagyan ng reinforcement ang concrete? Sa kadahilanan para tumibay pa yung concrete. Alam naman natin na ang concrete ay malakas sa compression pero mahina sa tension. Kung lalagyan natin ng bakal yung part ng beam under tension, mas madadala niya yung mga loads. Para sa mga engineering, ayaw nilang masira yung mga member. Pero if ever man or may mga senaryo na masisira yung structure, may mga certain way. For example, yung feature na to, pwedeng mag-fail sa ganitong paraan kung makikita nyo, may mga part na natatanggal sa beam. Sa mga ganitong senaryo, may mga ganito kung saan yung concrete yung unang nasisira. Tension control section. Section where the net tensile strain in the outermost layer of steel is equal or greater than 0.005. Tensile control beam or slab section. Such section are those where the extreme tensile reinforcement steel shall attain a strain GEQ 0.005 when the concrete extreme fiber in compression attains a strain of 0.003. Such design philosophy is considered to be a better option because it incorporates significant ductility into the system. For tension control section is greater than 0.005. For compression control section is less than 0.002. The transition zone is located between the compression and tension control section. Compression control beam or slab section. Give that the compression strain limit of concrete is 0.003 and the yield strain of grade 60 reinforcing steel is 0.002. Therefore, such sections are those where the extreme tensile reinforcement steel shall stay at the strain of LEQ 0.002. When the concrete extreme fiber in compression attain a strain of 0.003. The strength factor of member in the transition zone is computed using equation provided in Figure 1. Alternatively, you can use C over dt to determine the type of section. Section where C over dt is greater than 0.600 are categorized as brittle, and section where C over dt is less than 0.375 section are ductile. This is our topic. Thank you for listening. Sana may natutunan kayo. Keep safe and God bless everyone.